Okay, so this is a very common question about energy, and it talks about we're trying to look at the speed of something whenever it changes height. Okay, so it's saying a snowboarder of mass 55 kilos stands at the top of a slope that is 200 meters in height. So we've got some important information we can look at here already. So 55 kilos and 200 meters. So if we're going to do any maths, this is probably the stuff we're going to use. Okay, so there's nothing else here that we need to consider except for the fact that we need to find the speed, so that's what we're interested in. And we need to also ignore any forces of friction. Now that just means that we can look at things in a very simplified way. Okay, so we're not going to worry about air resistance, we're not going to worry about friction on the ground. So when we're approaching this kind of thing, essentially what we're trying to do is solve a problem. So let's look at how we might do that. And let's try and get our thing visible enough here. So this question is about kinetic energy and gravitational energy. So I might find it very helpful, in fact I do find it very helpful to draw a diagram to help me think about what's going on. Let me get the bottom of this mounted into shot. Okay, so we've got the mass of the snowboarder is 55 kilos and the total height of the slope is 200 meters. Obviously not to scale, otherwise this guy would be about 20 meters tall. So what we need to think about is what his speed's going to be at the end. Now let's think about that. Okay, we've got 55 kilos, we've got 200 meters. Are we going to multiply them together? Well, no, that's not very useful because multiplying mass by distance doesn't really get us anything that we find useful at this stage. So what we need to think about is, all right, so he's at the top of a mountain. He's got a certain quantity of something. He's got some gravitational potential energy, and we can calculate that. Because if we do E, I'm going to write E sub G, because that's the way I like to write it, but you can write it as GPE or whatever, okay? And I'm going to write it a bit bigger because it's a video. E sub G is equal to, now if you remember the equation, or if you remember the formula for working out gravitational potential energy, it is GPE equals M times G times H, okay? And there's going to be a change of height here, so he's going to lose a certain amount of gravitational potential energy. There might be more beneath that, right? But we're not interested in that. Okay, so we could lose more from going down here, but we're not interested in that. So we're going to look at the change of his gravitational potential energy for that change of height. So we've got his mass, simple, 55. Now G is something you need to remember, but this is the strength of gravity on that body, which in this case is Earth. It's going to multiply by 10, and the height there is 200. Now, here's where you need to be careful, because you could do all this absolutely fine, but if you're not careful in using your calculator, you're going to get a mistake. Okay, so what I would usually do is I would do the multiply by 10 straight away. So I've got fewer calculations happening, and it's quite easy. But anyway, let's do 55 times 10 times 200. Check what it says on your screen is okay. Hit equals, and make sure you didn't hit anything else by mistake. And what we get is 110,000. 110,000. And if you remember, just so we can talk about it, it is 110,000 joules of energy. Okay, so now we know the amount of energy at the top. What's actually going to happen here is all of that energy is going to get transferred as he goes down the slope into kinetic. At this stage, he's going to be moving slowly. They get faster and faster and faster and faster. So if you imagine if we had like a speed time graph, what we're going to get is something like this here. Okay, so we're not really interested in graphs right now anyway. Well, I am, but maybe you're not. So what we want to look at then is his kinetic energy. Now, if we're ignoring friction, that means that all of this gravitational energy is going to get transformed into kinetic. All of that will become kinetic energy, and that will be his kinetic energy when he gets to the bottom, when he's gone from A to B. Okay, so there he is. Okay. Those are supposed to be his arms. All right, all that gets transferred into kinetic energy. Now let's think about, can we remember our kinetic energy equation? Kinetic energy, which we usually write as Ke equals 0.5 times mass times speed squared, which is going to represent that with a V. Okay, 0.5 is just 0.5. That's the mass and that's the speed squared. Gives you kinetic energy. So let's look at that. If all that gravitation is turned into kinetic, that means that his kinetic energy at the bottom is exactly equal to that. 110,000 equals 0.5 times his mass. Now let's do a substitution now. His mass is 55 kilos times his speed squared. We don't know this, but this is what we are interested in. It's what we want to find out. So let's make our lives a bit easier. Let's take our 0.5 and multiply by 55, and that is going to get us 27.5 times v squared gives us 110,000. Now obviously we want to rearrange for finally to get to v, but of course we've got to do one step at a time. So v squared multiplied by 27.5 gives us this. So if we want to get v squared by itself, what we're going to have to do is on both sides we're going to have to divide by 27.5. So 27.5. Now because I've divided that, they cancel and it's gone. So that means that 110,000 divided by 27.5 is equal to v squared. Now, I'm going to pause here. A really common mistake is for people to forget there's a squaring going on here, okay? If we divide this, we're still going to get a really, really huge speed, which is too big for a typical snowboarder. So, let's take 110,000 and we're going to divide by 27.5. And that's going to get us 4,000. 4,000 meters per second is too fast for a snowboarder. So v squared is equal to 4,000. Okay, and then our final step. Again, people think, oh, I've got this by itself. I'm done. I'm happy. But you're not, because v is equal to the square root of v squared, and the square root is, well, remember one thing you can do with this is you don't need to put numbers in every single time, and the numbers won't always be nice and neat and easy to use like this. All right, but what you can do with the calculator like this is you can hit square root of the answer to the previous question. Answer, okay? And that will get you 20 root 10, but they'll want it in decimal form, so 63.24. 63.24 meters per second. So there you go, you get an answer. Now that is still too high for a typical snowboarder. That's very, very fast indeed. That would be very scary. But that's because what we're looking at is a situation without friction at all. And believe it or not, snow does give a substantial amount of friction.